So what we're going to do in this video is talk about some new trigonometric functions and then how to differentiate them. So what we can see here is that we've got three new functions, sec x, cosec x and cot x, and they are actually just the reciprocals of the trigonometric functions we already know. So for example, sec x is the reciprocal of 1 over cos x, and the graph would look like this. Cosec x is the reciprocal of sine x, and it would look like this. And cot x is the reciprocal of tan x, and it would look like this. Okay, so what's important to know is a lot of these different derivatives will be in a formula sheet, but you still should understand where sec x, cosec x, and cot x are coming from. Okay, so then what we're going to do is look at some derivatives of them. Okay, so here's the work we're actually going to look at. So what we've never done before is differentiate tan x. So that's the first one we're going to look at. If you have tan x, the derivative of tan x is sec squared x. The derivative of cot x is negative cosec squared x. Derivative of sec x is sec x tan x. And the derivative of cosec x is negative cosec x cot x. These are all given in the formula sheet. So they're the basic information that you're given. However, knowing that, you need to be able to apply that with all of our other information about differentiation. So let's have a look at some potential questions that could come up. Okay, so that first question, find the derivatives of the following. F of x equals cosec x tan x. Well, hopefully what you should realize is that that is actually just an example of product rule. Okay, where that's going to be derivative of cosec x and the derivative of tan x. They're two different functions. Okay, so using the product rule, we should be able to differentiate that. And remember the product rule, it is differentiate the first, leave the second, and then add, and leave the first, differentiate the second. Okay, so if we check our formula sheet, the derivative of cosec x is negative cosec x cot x, leave the second, and then we're going to add it to, if we leave the first one, and then differentiate the second one, which is here, differentiate tan x, we're going to get sec squared x. And that's actually it. Although what we could actually hopefully see is that we can, within that answer, simplify. Okay, we've already learned that tan x and cot x are related. Cot x is just 1 over tan x. So that means cot x and tan x will cancel out. We know that sec x is just 1 over cos x, and we know that cosec is just 1 over sine x, which means none of them is going to cancel out. Okay, but we can rearrange that to just be negative cosec x plus cosec x sec squared x. And then if we were going to be really neat, we could take out a common factor of cosec x, which would leave negative 1 plus sec squared x. Okay. Moving on to the next one. We've got the derivative of tan squared of 4x. Now hopefully what we can realise is that I'm going to rewrite that as tan 4x all squared. And we're going to hopefully see that that is just chain rule. It's new things that we're differentiating, but we know how to do this from what we've learned already. So that means f dashed x is going to be differentiate what's outside the brackets to the power 1 times by the derivative of what's inside the brackets. Okay, so we leave that there. Derivative of tan x is sec squared x. So that's just going to be sec squared 4x times by the derivative of what's inside the brackets, because it is just chain rule within chain rule. And the derivative of 4x is 4. So we get 2 tan 4x dot sec squared 4x all times by 4, which means our final answer will just be 8 tan 4x sec squared 4x. Okay, so it's using all the information we've had before, but we're just learning new derivatives. And always remember, these are given in the formula sheet. Okay, so that's our new trigonometric functions.